our player can run, he can jump, he can collect stuff, he can die, but sometimes he might just want to relax for a little bit. So in this part we will create moving platforms in our game world where the player can jump on and then be transported around with it. I think that's a really cool feature and we will learn a lot of new stuff in the process, so let's go. So back in the Unity editor, first of all, let's make our game world a bit bigger. For this we open the grid, because here we draw our tile map on, and I'm gonna start with the background. And I switch to the tile palette, make sure that the active tile map is set to background. Select our background here, I used the rectangular drawing tool. And when we jumped, it was, so now I can see our, let's go. Let's make our game world a bit bigger. For this we open the grid, because here we draw our tile map on, and I'm gonna start with the background. And I switch to the tile palette, make sure that the active tile map is set to background. Select our background here, I used the rectangular drawing tool. And when we jumped, it was also not high enough, so I go a bit bigger. And it's better to make it a bit too big than too small. And then what I want to do is I want to have a part here in the middle with spikes on it. That's too big for the player to jump over. Instead he has to jump on the moving platform and get transported over it. So first of all we have to select the terrain tile map. First of all, let's make our game world a bit bigger. For this we open the grid, because here we draw our editor. First of all, let's make our game world a bit bigger. For this we open the grid, because here we draw our tile map on, and I'm gonna start with the background. And I switch to the tile palette, make sure that the active tile map is set to background. Select our background here, I used the rectangular drawing tool. And when we jumped, it was also not high enough, so I go a bit bigger. And it's better to make it a bit too big than too small. And then what I want to do is I want to have a part here in the middle with spikes on it. That's too big for the player to jump over. Instead he has to jump on the moving platform and get transported over it. So first of all we have to select the terrain tile map, otherwise we are drawing on the background. A part here in the middle with spikes on it. That's too big for the player to jump over. Instead he has to jump on the moving platform and get transported over it. So first of all we have to select the terrain tile map, otherwise we are drawing on the background. Then I'm gonna select this piece here, the left part, put it here next to our platform. Then I pick the middle piece and the rectangular drawing tool, so I can draw a long piece like this. And the right piece. And put it here. Then I'm gonna use the pick tool, where I can select tiles from my tile map, and then I select a big piece like this and put it here. And of course this also needs the ending part like this. And then I wanna put spikes onto this middle piece. So let's open traps, select one of those spikes and press Ctrl D, with which you can duplicate them. Then I hit W to select the move tool and put it down here. Like this.
Test it out. Oh.
And then I go ahead and use Ctrl D to duplicate this few more. And luckily we have them all nested under our traps object here, so I can just close it and our hierarchy here doesn't become too messy. And then we want to put our moving platform here. And the sprite for it is under Assets, Pixel Adventure, Assets, Traps, and here we have platforms. Two different ones, you can pick whatever you like. I'm gonna pick this one, and we will skip this one with the off animation state and just use the on animation state. And it consists of an animation. It's a really subtle animation where something is rotating, but it will look cool later. So let's right click in our hierarchy, create a new 2D object, and here we have platforms. Two different ones, you can pick whatever you like. I'm gonna pick this one, and we will skip this one with the off animation state and just use the on animation state. And it consists of an animation. It's a really subtle animation where something is rotating, but it will look cool later. So let's right click in our hierarchy, create a new 2D object, sprites square. Let's call it moving platform. And by the way, you can put white spaces in this name, doesn't matter. You can only not put white spaces into C# scripts, or C# script names rather. So we click on moving platform, switch to the inspector, and then we drag the first image of our animation onto the sprite tab here. So we can see it, but of course it's small, so let's select it and set the pixels per unit value to 16 and hit apply, and there it is. Next, let's select the platform in our hierarchy again and move it up a little bit. And we can either leave it like this without an animation, or we can add the animation, which looks cooler. So let's do this. Let's switch to our animations folder, create a new animation, and call it moving platform. Then we drag and drop this animation onto the moving platform game object to get our animator. Then we open the animation window. We select moving platform. We switch back to the folder with the animation graphics in, which was here under traps and platforms. Then we drag them all, which that's the whole animation. It's very subtle, but it gives more life to the game. And now we want to move this platform back and forth between this middle part here. And one way to do this would be to add a rigid body to this platform and then apply velocity and maybe change it every 2 seconds. But it's very imprecise to use a time for that, and it's also dependent on the speed. So when we change the speed, we have to change the duration. Wouldn't it be cooler if we could add waypoints to it so that we can say, okay, we want to move exactly between this point here and this point, and maybe additional points in the future. And in Unity you can do pretty much anything you want, so let's try to build this. Let's close this animation window, and for our waypoints we can just use normal game objects. So we create empty and we call it waypoint 1. When we select it, we can see where it is. If you can't find it, you can also hover with your mouse over the scene viewer and press F, and then it should zoom somewhere to it. Now, since it doesn't have a sprite renderer, it's not visible at all, unless we have it selected and see these tools here. And this makes sense because we don't want to have this waypoint visible when we start our game. But it would still be useful if we could see it while we are editing our scene. So what we can do is we can select it in the hierarchy and then click up here and give it one of these icons. Doesn't matter which one you pick. And then you can see it just here in the scene viewer, but we will not see this in the game. So let's set the waypoint to the same height as our platform. So the platform has a y of 0.18. Let's copy this and set it to the waypoint as well. And as you can see, the Z platform has a y of 0.18. Let's copy this and set it to the waypoint as well. And as you can see, the Z value is -6. Sometimes this happens when you add a new object, and it's still in front of the camera, so this would still work, but it's actually better if we set this to and set it to the waypoint as well. And as you can see, the Z value is -6. Sometimes this happens when you add a new object, and it's still in front of the camera, so this would still work, but it's actually better if we set this to 0 with the rest of the world. And then let's move it over to the edge here. Then we duplicate this waypoint with Ctrl D, but I'm gonna rename it because this genius naming convention here is not so great. Let's call it waypoint 2, and then we just drag it over, but we bend down slightly with the end here. So we create another empty game object. Let's call it moving platform 1. And just for organization, we put these 3 objects here below it, so we can open and close it. Next, let's write the script that's responsible for moving this platform between these 2 waypoints. So we go into our assets folder here, into scripts, right click, create a new C# script and give it a name. Now we could call this platform movement, for example, but it makes sense to give it a more generic name to keep it reusable later. And we will actually reuse this script later on a different game object. So instead of platform movement, let's call it waypoint follower. In Pascal case without white spaces. With this name, the script is more reusable, because we can put it on other game objects and it still makes sense, right? Before we write the code for the script, let's drag and drop it onto the moving platform. Not the empty game object, but the one that actually contains the animation. So this component is applied to this object. Then we double click on it here and write some code. Game code can put it on other game objects and it still makes sense, right? Before we write the code for the script, let's drag and drop it onto the moving platform. Not the empty game object, but the one that actually contains the animation. So this component is applied to this object. Then we double click on it here and write some code. And this time we don't move our object by adding velocity to it. Instead we basically want to set the positioner directly frame for frame. And we already know where we can do something each frame in update. So this time we don't need start, so we can delete it. And I'm also gonna delete this comment here. And then I make update private. So the script we will be writing here will not be very big, but the code is new and might be a bit complicated the first time and a bit difficult to understand, but don't worry about it, just follow everything step by step. It's not a problem if you don't understand it the first time. So first of all, we need a way to understand the code is new and might be a bit complicated the first time and a bit difficult to understand, but don't worry about it, just follow everything step by step. It's not a problem if you don't understand it the first time. So first of all, we need a way to hold our different waypoints. But instead of adding 2 waypoints, we also want to have the option to add 3 or 4 or 20 waypoints in the future if we want to have more complicated movements. So instead of creating a variable waypoint 1 and a variable waypoint 2, we create an array. An array is a variable where we can put more than one value in. And it looks the following way. First of all, of course, it has to be a serialized field, so we can set it in the editor. And then we create a private. The type is game object, which is basically the generic super type of an empty game object. So our waypoints, if you remember, don't have any components in them. They are just empty game objects. So this is why we declare the variable type just as game object like this. And now to be able to put more than one game object into this variable, we add a pair of angle brackets here, which creates an array. We give the variable a name, let's call it waypoints and close this with a semicolon. Let's already save this with Ctrl S, go back into Unity and see how this now looks in the editor. So we select our moving platform and now here we have this drop down menu for our waypoints and we can add a list of waypoints to it by clicking plus. Let's click it 2 times because we have 2 waypoints. And then we keep moving platform selected and drag the first waypoint into element 0 and the second waypoint into element 1. And now they will be put in the array when the game starts and we can use them in our script here through this waypoints variable. Next we need a variable that keeps track of the current waypoint index, so we know what waypoints we are currently moving towards. This one doesn't have to be a serialized field because we don't need to set it in the editor, it's managed within the script. So we just create a private int for a number and call it current waypoint towards. This one doesn't have to be a serialized field because we don't need to set it in the editor, it's managed within the script. So we just create a private int for a number and call it current waypoint index and initialize it with 0, which is the first index for the first waypoint. And the last variable we create here, and I put an empty line between it because they are not logically related, that's just for organization, is the speed with which we want to move our platform. And to be able to change it in the editor later, we make it a serialized field, and we create a private float speed and initialize it with 2 as a float. And now we write some logic inside update to set the position of our moving platform each frame. So inside update we write if parentheses vector2.distance. This way we can check the distance between the platform and the currently active waypoint. So we know that we get close to it or we touch it. We want to switch to the next waypoint so we can move towards it. And this is exactly what this vector2.distance method does. It calculates the distance between two vectors. So the first vector is the position of the currently active waypoint, right? And the second vector is the position of the moving platform. Exactly what this vector2.distance method does, it calculates the distance between two vectors. So the first vector is the position of the currently active waypoint, right? And the second vector is the position of the moving platform. Waypoint, right? And the second vector is the position of the moving platform. So we write waypoints, which is our waypoints array, and then we want to access the first waypoint by its index, which we do by writing a pair of angle brackets again, and the index of the currently active waypoint, which is our variable here. So current waypoint index. Then we want to get the position. So we move the cursor out of the angle brackets, write transform, we already know this, dot position, comma, and the second vector, which is just transform.position, which we also already used earlier. That's the position of the object the script here lives in, which is the platform in this case. And then we go outside of the first closing parentheses here. Write the less than sign. If the distance is 0, we want to switch to the next waypoint. But again, there is a little bit of imprecision here, so we can't write exactly equals 0, otherwise it will be buggy. Instead we use a small value. Let's use 1.f here. So this basically means if the current waypoint and the platform have a distance of this very small fraction here, then we know that we are basically. So this basically means if the current waypoint and the platform have a distance of this very small fraction here, then we know that we are basically touching it, and then we want to switch to the next waypoint, which we do inside the curly brace block of this if statement here, because this part just returns true or false in each frame. So here of course we want to increment the current waypoint index like this, and then when we are at the last index we need to switch back to the first one, right? So we cycle between these waypoints. So below we write if current waypoint index is greater than or equal to waypoints dot length, which is the size of our waypoints array. This way we know that we are at the last waypoint. In this case we want to reset the current waypoint index to 0. It's actually pretty straightforward when you think about it. And now we only have to write one more line and the script is already done. And it's important that you put the line at the correct place, because it can be confusing here with all these closing curly braces. We want to put it below the outer if statement. And here we want to move our platform a little bit towards the next waypoint, because this is the next frame. And then, as I already explained, we don't want to use velocity here. Instead we will move our platform directly frame for frame. So we want to set the transform position of this platform object directly. And to calculate this new position we have a nice helper method, which is vector2.moveTowards. And the first argument here is the current position, which again we get the transform platform directly frame for frame. So we want to set the transform position of this platform object directly. And to calculate this new position, we have a nice helper method, which is vector2.moveTowards. And the first argument here is the current position, which again we get with transform.position. And the second argument is the position we want to move towards, which is the same as up here. Waypoints, current waypoint index, .transform.position, so we can actually just copy this, put it behind the comma, add another comma because this takes a third argument. And this third argument defines how far we want to move in this frame, because remember this is only one frame and we don't want to move our platform to the waypoint only in one frame because this would be instant. Instead we write, and don't get scared by this, time with capital T dot delta time times our speed, and we close this line with a semicolon. Now the speed value here defines how many game units we want to move our platform when we call this method. And we close this line with a semicolon. Now the speed value here defines how many game units with a delta time times our speed, and we close this line with a semicolon. Now the speed value here defines how many game units we want to move our platform when we call this method. We have set this to the value 2. Don't get scared by this. Time want to move our platform to the waypoint only in one frame because this would be instant. Instead we write, and don't get scared by this, time times our speed, and we close this line with a semicolon. Now the speed value here defines how many game units we want to move our platform when we call this method. We have set this to the value 2, so we will move 2 game units when we call this method, and 1 game unit is 1 rectangle here in our player world, which is also 1 piece in the tile map. But of course we don't want to move 2 game units in 1 frame because this would be extremely fast. Instead we want to move 2 game units per second. Now the problem is that update is called every frame, but we don't know the frame rate of the current system. If we have a frame rate of 30 frames per second, we have to move at a different amount per frame than on a device where the frame rate is 60. And this is where this time.delta time comes into play. When we hover over it, we can see the documentation comment, which says the interval in seconds from the last frame to the current one. So this is a tiny value, a fraction of a second that has passed since the last frame. And if the frame rate is higher, this value will be smaller. If the frame rate is lower, this value will be bigger. And this is what we use whenever we want to make something in our calculations here frame rate independent. By multiplying our speed value with this delta time, we now move 2 game units per second, no matter what the frame rate of the device is. Now it's hard to wrap your head around this the first time, but if you think about it for a bit, I'm sure you will get it. But game unit. By multiplying our speed value with this delta time, we now move 2 game units per second, no matter what the frame rate of the device is. Now it's hard to wrap your head around this the first time, but if you think about it for a bit, I'm sure you will get it. But this time.delta time value is very common in Unity games, so you should get used to it, because you need it to make your games frame rate independent. So now this should already work. Let's save it and go back into Unity, let it reload, and we have already set the waypoints. So now we should be able to just start it. and our platform should be moving. And it's seems to work. Oops. We can keep it playing but zoom out and everything, which can be very convenient, and we can see that it moves back and forth. But of course we can't yet jump into it, click on a box like this and see if this already works. And this works, but if we don't actually move with the arrow keys, we just keep our position. So we need a way to tell the game that we want to move with this platform, otherwise we will just slide off. And if you remember in the very beginning, before we wrote our camera controller script, we nested the camera under the player game object to automatically move it with it. And we can actually use the same behavior to move our player with the moving platform. This is the easiest way to go about this. So let's create a new script for this. In our scripts folder, new C# script, and I'm gonna call it sticky platform. I drag and drop the script onto the moving platform, and then we double click it to edit it. And what we basically want to do is, we want to check if the player touches the box collider of the moving platform, and then parent the player under this moving platform object. So let's do this. We don't need start and update, instead we just want to get notified when we touch the collider of the moving platform, which we can find out with onCollisionEnder 2D. If you don't have auto completion in your editor, just type it out manually, like here. Here we check if collision, which is this argument again, .gameObject.name. This time we don't need to add a tag to our player because we only have one player and it will always have the name player. So instead of adding a tag like we did for the cherries, we can just compare the name. directly, which we do like this, .name and two equal signs, which we use to compare two values in C#. And we want to compare to the string player, which of course, as usual, has to have the exact same capitalization as the name of the player here, and this inside the moving platform as a child. This part will be executed if this sticky platform collides with another collider and if this other collider has the name player. Then we want to put the player inside the moving platform as a child, which we do like this: collision.gameObject, which again is the game object we collided with, .transform .setParent, which is a method where we have to pass what we want to set as the parent of this game object. And here we just pass transform, which is the transform component of the sticky platform, because we have written this with a lowercase t. We've already used this before. And this will set the player as a child of this moving platform. But then we also need to do the opposite when we leave the moving platform. So we also override on collision exit 2D and do the same check again. So we copy this whole if block here. But instead of setting the platform as the parent, we want to remove the parent, which we can do by passing null, which basically means no value. We save this and go back into Unity. Select the moving platform again and set the layer to ground. Why? Because otherwise we can't jump while we are standing on it. And here, this moving platform. When we leave it, we revert this and the player is its approach, because we check if we revert this and the player is its own game object again. But there is still one problem with this approach, because we check if we hit this box collider, we also get dragged forward together with it, because we are touching the box collider on the sides. This means we parent the player to the moving platform and then we get moved together with it. Now to get rid of this, we actually have to add a second box collider just here on the top, so we can distinguish between touching the sides and really touching the top, which is what we care about. So let's take care of this. We select our moving platform, and we can actually add a second box collider to it. And now we have to change the boundaries of our new box collider. But before we do this, let's change the order of the components here in the inspector. This is just for organization. You can actually move them around, but for some reason this only works if they are collapsed. So we collapse them with this arrow, and then I drag and drop the lower box collider here, which is just a better organization in my opinion, because we have our two box colliders below each other. And now we have two different box colliders that we can edit independently from each other. If you don't know which one is which, you can untick them here and it will make the color slightly less visible. So this is the first box collider we have already set up, but let's make it a bit smaller on the height, and let's put a new one on top of it, because we only want to be able to stick to the top of the platform. Let's put it like this and make the edges a bit smaller, otherwise we can still collide with it when we touch the sides of our platform, which we don't. Want. So this looks good in my opinion. Next we have to make the second box collider, the new one here on top, a trigger. Otherwise we can't distinguish between these different box colliders in our code, because in both cases, no matter which one we touch, only the onCollisionEnder method will be called. But by making one of them a trigger, we can distinguish between them the following way. So let's go back into our our sticky platform script, and now the top box collider, the one that we actually care about, is a trigger. And we have already used a trigger earlier when we set up our cherry items. And remember, instead of onCollisionEnder, when we touch a trigger, we get called onTriggerEnderToDear. And this is how we can distinguish between the box collider that is not a trigger. When we touch this one, those methods here will be called, and the one that is a trigger will call onTriggerEnderToDear and onTriggerExitToDear. So we simply cut out these parts and put them into the new methods. And the one that is a trigger will call onTrigger enter to dir and onTrigger exit to dir. So we simply cut out these parts and put them into the new methods, and delete these ones because we don't want anything to happen when we touch the outer parts, the lower box collider. So, after you have made these changes, let's save the script. Go back into Unit here and try it out, because now we should only stick to the platform when we actually touch this part here on top. So let's hit play and try it out. And now when we touch the sides of the platform, we shouldn't stick to it anymore and we shouldn't get dragged behind it. So this seems to work. If your player still gets dragged with the sides of the platform, try to fine tune your box colliders. Make sure you're not touching the trigger. Slight thing, we can touch this round part, the feet are in front of it. And of course we can fix this by changing the when we jump on top of the platform. Now one slight thing we can change is, you can see that we are in front of our platform here. We can see it when we touch this round part, the feet are in front of it. And of course we can fix this by changing the sorting layer, as we already did for our tile maps earlier. So we select the moving platform, and here in the sprite renderer we have the sorting layer. Now instead of setting up a completely new layer for the moving platform, we can also change the order and layer value here to change the order within this default layer, and you can do this for all your sorting layers. Which one you choose, either changing this value or creating a completely new sorting layer, is up to your personal preferences and how you want to organize this. But when we set this to 1, it will be in front of the player because the player also has the default sorting layer, but with the order and layers. Zero. So let's try it again. Jump onto our platform, and now we are behind it, which looks much nicer in my opinion. Okay, nice. And lastly, let's make our moving platform a prefab so we can reuse it later. But we don't want to make the whole folder here a prefab because we want to use different waypoints later for our new moving platforms. So we only drag and drop the inner moving platform object here into our prefabs folder. And now we can put more of them into our scene viewer, and when we make changes to one of them, the changes will be applied to all moving platforms. Okay, this was really cool. In the next part we will combine our new waypoint follower script with a new kind of trap to create the ultimate super weapon. So stay tuned for that. Now what I find